Well, it's probably true that we could tell the whole history of computing just by looking at character sets. We're not going to go that far. We just want to see what we need to do in order to represent data properly in our database. We all know, though, that even at the most superficial level, computers just store data as binary. That's a series of ones and zeros. It leaves unanswered the question, though, like, well, how do you get there? And especially representing text, there have been several different systems in the olden days, 50s, 60s, even into the 70s. Every different computer system you could possibly buy represented text differently. And here's one of the really popular ones that started in the 70s. It was done by the American Standard Code for Information Interchange. That's what it was called, or ASCII is how you pronounce that. Sounds like you're saying something dirty, but you're not. And this is actually the chart that was used by the computer to convert text into ones and zeros, and conversely, to convert ones and zeros back into text. So let's just imagine that I want to use the capital letter A. Well, what I would do in that case, in this chart, is I would go all the way over to the left, and that's where you can see a bunch of zeros and ones. Those are the front end of the zeros and ones. And then I would finish by looking at the top of the column to get the remainder of the zeros and ones. So I'd start over here, and then I would go all the way up to the top, and that would give me my representation. So those are 7 digits, or 7 bits. ASCII was always 8, and the first one was a 0. So you can see the pattern there. It starts with a 0, and then you go 0, 0, 0, 1 because that's on the left, and then you get 1, 0, 0 because that's on the top. Now, if your computer sees that pattern and it knows that it's looking at text, you just do the reverse process. You divide that, you look on the chart, and then you find the intersection of the row and the column, and you know that's a capital letter A. Great. Let's fast forward a little bit. Here's what it looks like if you happened to have, say, a Macintosh of version OS 9 or earlier, that is to say before the year 2000 or so. And Macintoshes before the year 2000 used the character set on the right. But if you were on Windows, you used the character set on the left. These are actually the same size squares, it's just that there's a little more data on the left. But let's imagine that I'm doing something. Let's say that I'm on my Macintosh and I'm using a word processor. It doesn't even matter which one. And I type this letter. That is a capital letter A. Now it's hard to see, with a little circle or a ring on the top. Now, same trick. If I go over to the left, you'll see that there is an 8 and an underscore. So these are all going to be 2-digit numbers. So the first number is an 8, and then if I go to the top of the column, you'll see there's underscore 1. So this is at character position 81. That's a number. We could also call this code point 81 or character position 81. So let's say I write my document and it has that character in it, and then I send it to my friend who's on Windows. Well, that word processor uses a different character set. But when it gets to that data, that bunch of zeros and ones, it says, well, hey, that is character number 81. So I'm going to interpret that as character number 81 on the Windows 1252 character set, which is right here. But there's nothing there. There is no character in the Windows character set at position 81. So the software just has to make a decision, like, well, what do you do if there's no character there? Some of them might put in, I don't know, a square box. Web browsers sometimes do kind of a diamond shape. You get a black diamond with a question mark in it. Sometimes you just get a question mark, or you maybe get an upside down question mark or something like that, just to signify that there's no character at that position in the chart. So let's just go farther. Let's imagine that my friend says, hey, look, I know what you were trying to do. You needed the A with the circle on it. Maybe he doesn't trust me that I actually typed it properly or something. So what he does, very, very kindly, generously, he says, I'm going to fix all that for you. So I'm going to put a real A with a circle on it. Well, in the Windows character set, that's down here. It's actually at position C5 in the grid, or we could say at code point C5. So he fixes all that, and he's like, no, I fixed it for him. Go ahead and use it. And he sends it back to me. But now that character is C5 in binary digits. So my Macintosh looks in the chart to see what's at character code point C5, which is right here, which is an equal sign with a squiggly. It's a squiggly equal sign, almost equal to. So we're having this sort of mismatch, right? The two character sets are not the same. The underlying bits, or the digits, zeros and ones, remain the same. This is just like a decoder ring. How do I encode and decode those numbers as characters? And these charts tell us how to do it. Well, by the time you get to the late 1980s, this is a real pain. Trust me. I lived through the late 80s. This was not fun. So what a bunch of people did, in fact, people from Apple and I think maybe Xerox and a couple of other places, got together and they decided they were going to create a new character set, the one character set to rule them all. And by 1991, they had a draft proposal, and version 1 of this came out called Unicode. Unicode is giant, absolutely massive. It has a code point, or a square on the grid, for every character from every language on the planet. And in fact, more, the Trekkies found some places in the corners of Unicode that weren't being used right now, and they put Klingon characters in there. And the Unicode Consortium said, well, it was a good trick, but we don't recognize that as an official language. So that's okay. So here's what this means. By now, everybody should be using Unicode, because now every character on the planet is open to us. Now, your computer might not be able to display those. You have to have a font that can display those. But in terms of the binary digits under the hood, zeros and ones, we can store anything. As long as we're working in Unicode, everything is possible for us. What that means is that doing our DH work, we should be using Unicode for everything, including all the work we do in the database. So let's look at a couple of things. We'll look at the database, then I want to look at clients, and then I want to look at the text editors at the end here, because this is where we're going to be doing all of our work. When we create a database, we're going to do this on the command line. This is the statement we're going to use. We're going to say to MySQL, hey, create database. We will give that database a name, but here's the crucial part for us right now. We're going to add onto the end of that default char set UTF-8, right? Default character set UTF-8. UTF-8 is the shorthand in MySQL to define something as Unicode. And what we're saying here is that every table, every column, every cell or field that contains text will be Unicode. Everything. We don't need to specify that anymore because we have told MySQL here that the entire database is Unicode. And why do we want to say that? Well, for some reason, MySQL, unless we tell it to do this, will default back to Windows 12.52. And so that's not necessarily for us the best decision. So until that changes, until the default character set for MySQL does become UTF-8, we just want to make sure that it is. So this is how we'll define our database. For those of you on Windows, you already know that you are installing a command line client, and they show up in the start menu down in the bottom left-hand corner. We've already seen too that they have multiple ones, but there are at least these two of them. Here's the shtick about what those things are. The top one there is actually a Windows 12.52 client. Now our database is in Unicode, so that is not the one we want to use. The other one right below it is MySQL 8 command line client dash ... And those of you who have probably with this know that ... is because it can't squeeze in the word Unicode right there. But that's the one we want to use. So we always want to be using the Unicode one, and it makes sense, right? I mean, our database now is in Unicode. Our client should be in Unicode. Our text editors will need to be in Unicode. We want Unicode everywhere, all the time, constantly, and then we'll be okay with characters. Now, if you're on a Macintosh, we're using the terminal application. And when you have terminal open, go under the preferences to terminal, and then you'll see there are 4 icons here at the top of my preferences panel. I'm on the second one called profiles. And then, I know this is so buried in here, you'll notice on the right hand side there are 6 tabs, and the most right hand tab is advanced. So I'm in profiles, advanced, and then if you look way down at the bottom, you'll see a pop-up menu for text encoding, and you'll see that it's set to Unicode or UTF-8. That's what it should be. Now, maybe it's set that way automatically already. If so, terrific, just leave it. If it isn't, make it so. Make it be Unicode. Again, same thing. If the database is in Unicode, the way in which we interact with the database should also be in Unicode, and then we're not going to have any character set problems, right? All right. And then finally, the last part of it is the text editor. As we go along, we're going to be doing a ton of kind of data entry work and other things, query work in text editors. So text editors, especially if you get one of the professional ones for programmers, are really, really, really good at working with character sets, and they can recover a ton of problems. So let's just flip over into a text editor here and we'll take a look. Now every text editor is going to be different. So if you're not using one of the two, I'll probably look at Sublime here and maybe BBEdit. But if you're looking at something else, you're just going to have to play around with it so that you can find out how to see what character set you're working in or how to change it if you need to. Well, here I just have a couple of text editors open in a command line tool that I'll show you here in a second. All I wanted to do was to look at how these different text editors approach character sets and what happens when they're trying to open a document that is in a different or a wrong character set. So here in the front, in the white screen is, on my Mac, it's BBEdit. And you'll notice we've got a giant text file here with one character. This is our friend A with a circle over it. But if you look down at the bottom, there is a pop-up menu here, and you can see that the current character set is Western Mac OS Roman. Now that's a menu, and if I click on it, here are all of the other character sets that BBEdit understands. Here's Windows Latin 1, we've got some Chinese character sets, Korean, Japanese, Cyrillic for Russian stuff, and a bunch of Unicodes up here at the top. Now, if I look at that document from the command line, I can do that with a tool called octal dump, a very elegant tool. I can see what the number is, and you'll see that that's just number 81. That's what we saw in the Mac character set, right? Now, if I go over to Sublime and I choose to open that document, I'm just going to go under File, Open. Here's my Mac A, and if I open it, you'll see what I get. It's a hexadecimal number. That's what the 0x means, and it's just 81. And it can't really display that character. Now, it's because in Unicode and there's nothing at 81. So we said earlier that the software will figure out how to display a character when it isn't there. And this is how Sublime chooses to show a character that isn't there. Now, if I do something else, if I say I want to reopen this document with a different text editing, I can't run my computer, but you'll see there's a bunch here. There's a couple of Westerns, some Arabics. There's more here, Baltics. There's all kinds of these. But one of them is Mac OS Roman. And so if I open this with Mac OS Roman, now you'll see that I get my A back again, right? Now, if I create, or if I save this, let's just do this. Let's save this document now. I want to go under Save with Encoding, and I'm going to change this to Windows 1252. So I've saved that. Now if I go back and look in my BBEdit, you'll see what's happened. This still thinks it's in Roman, Mac OS Roman, but you'll notice now it has changed to the curly equals sign, which is exactly right. So this has now changed to C5. So if I do my octal dump again, oh, now you'll see that I get nothing. It can't display that. It's going to be a character at C5. But you'll see that, right, I'm moving back and forth between those two characters that we saw on those charts, right? It's A with a circle over it, or it's that tilde sign. So one of the things that we want to do in our text editors is that we always want to be working in like Unicode UTF-8. We'll save in that. We'll open new documents in that. Go into the preferences of your various text editors and just make sure that you're always using default UTF-8 as the character encoding set. That's how I have BBEdit set for me, and that's how I have Sublime set for me. Those are probably the settings for the default when you download those and install those. So if you don't mess around with them, I think everything is going to be fine. But again, these programming text editors are really, really, really good at character sets. So if you get data that's in the wrong character set, you can use your text editors to help fix it. Two quick issues, and then we'll be done. You may see when you're working with a database this notion of a collation sequence. A collation sequence is just simply how any given language orders its alphabet. Different languages have different characters, and how they sort those to go in alphabetical order is all different. So, for example, here's one on the left. This is the German alphabet, and you'll see there's an A umlaut, and there's that weird SZ character, and some other things, an O with an umlaut. So how those characters fit into the alphabet, and when you're doing things in alphabetical order, matters. On the right, this is the Norwegian alphabet, and you'll see here at the end is our friend A with a circle over it. And it's interesting that they have a Q in their alphabet, because the Norwegian alphabet historically does not have a Q, and being as somebody who is of Norwegian descent, all my relatives and ancestors spell the name with a K. But anyway, be that as it may. So collation sequences are just how the alphabet sorts its letters. Now, it is conceivable then that you could have everything in Unicode, but if you're working with the Germans and they want their stuff sorted in a particular way, you may need to redefine the collation sequence on a table or a column, and that's totally possible to do. We're not going to do that, but it is totally possible. So you could have, for example, a table or a column that the character set is UTF-8, but the collation sequence is German. And that's entirely possible and probable. And so just be aware that that's a thing you could do. The second thing is that the programming languages that we use when we work with databases these days, more and more and more of them are Unicode savvy, but they're not all there. Perhaps the most popular one right now is Python. And I teach Python quite a lot. As long as you're using version 3 or later of Python, you're totally Unicode savvy. So don't worry about it. It knows Unicode. It knows how to work with Unicode. JavaScript since 2015 or so is, Ruby is. Some of the other languages like Perl and PHP are maybe not necessarily there yet. PHP is incredibly popular on the web, but it isn't necessarily always Unicode happy. And so if you're working in PHP, look at things like multi-byte functions, because there are some ways that you can work around any limitations that it has about Unicode. Now, when you get into the technical details, you might need to dive deeper than you really wanted to. And so here, for example, is just a little blog piece that's really straightforward and nice about what every JavaScript developer should know about Unicode. So if you're working with these languages a lot, you're working with different alphabets, these are really great things to know when you have to dive into the technical details. Like, you're having a problem. Why am I having a problem? That's when you have to go down these rabbit holes. But Python is one of the great languages for text analysis. And so if you're working with Python, really, you got nothing that you have to worry about. It's going to be fine. All right, well, that's it for character sets. I appreciate that. I know character sets are not maybe the sexiest thing when you're working with databases, but they're really, really important. And the lesson, obviously, and everything that we've done in this little lecture, use Unicode. It is your friend, and it is the one ring to rule them all. Thanks.